No pilot, leh? Ever looked up and seen a buzzing machine in the sky? Maybe you've wondered who's controlling it, or if there's even anyone at all. That's probably a drone, often flying all by itself, no pilot inside, sometimes not even someone with a remote. It's not just a toy or a gadget. It's a glimpse into the future of technology, right above our heads. Imagine a smart, flying robot, able to make decisions and navigate our world solo, weaving through buildings, trees, and even crowds, all without direct human control. Sounds like something out of a sci-fi movie, right? But it's not just fiction, it's happening right now, right here in Singapore, and in cities all around the globe. Drones are becoming a part of our everyday lives, whether we notice them or not. These are autonomous drones, machines that can take off, fly, do a job, and land all on their own. They're delivering packages, inspecting buildings, surveying land, and even helping in emergencies, all without a human at the controls. How do they pull off these incredible feats? It's all thanks to a mix of clever engineering, advanced sensors, and powerful computer brains packed into a small, buzzing package. These drones are constantly collecting data, making split-second decisions and adapting to their surroundings. So, buckle up. We're about to dive into the science, sensors, and smarts that let drones fly themselves, tackle real-world challenges, and change the way we live, work, and explore our world. Have you ever wondered how a drone manages to soar into the sky, even though it doesn't have wings like a bird or flap them like an insect? It almost seems like magic, but there's some fascinating science at work here. Most drones you see today, especially the popular quadcopters, rely on 4 powerful propellers. These propellers spin incredibly fast, slicing through the air and pushing it downwards. This downward push creates something called lift, which is the force that lets the drone rise up and hover in place. When the lift generated by the spinning propellers becomes stronger than the pull of gravity, the drone lifts off the ground and climbs higher into the air. It's a delicate balance, but when done right, up the drone goes. But flying isn't just about going up and down. To move forward, the drone tilts its body slightly, making the back propellers spin faster than the front ones. This tilt changes the direction of the lift, pushing the drone ahead. The same trick works for moving sideways. Just tilt left or right, and the drone glides smoothly in that direction. Turning, or what's called yaw, is another clever move. By making the propellers on opposite corners spin at different speeds, the drone can rotate on the spot, spinning like a top to face any direction it wants. The terms pitch and roll might sound complicated, but they're just ways to describe tilting forward and backward, or left and right. These movements let the drone dodge obstacles and make sharp turns in mid-air. By combining all these movements, lift, thrust, yaw, pitch and roll, a drone can zip, dart, and weave through the air with incredible agility. This is how drones race through courses, perform tricks, or capture stunning aerial footage. Behind the scenes, a tiny onboard computer is constantly making split-second adjustments, controlling each propeller's speed to keep the drone stable and responsive. Sensors help it stay level, avoid obstacles, and even fly itself if needed. It's like a ballet of physics and technology working together. So the next time you see a drone gliding smoothly through the sky, remember, it's not magic, and it doesn't need to flap. It's all about clever engineering, spinning propellers, and a lot of science. For a drone to fly itself, it needs to sense its world. That's where sensors come in. GPS tells the drone its global position, like a map saying, "You are here." Cameras act as eyes, letting the drone see and even recognize objects using computer vision. LiDAR shoots out laser beams to build a 3D map, helping the drone avoid obstacles with pinpoint accuracy. The IMU, like an inner ear, keeps the drone balanced, measuring tilt and movement. Ultrasonic sensors help with close-up detection, like landing safely. With all these senses, drones can see and feel their way through the world. Sensors are the eyes and ears of a drone, collecting raw data from the world around it. But it's the AI that acts as the brain, interpreting all this information and making smart decisions in real time. Without AI, a drone is just a flying machine with no real understanding of its environment. AI seamlessly fuses data from GPS, cameras, LiDAR, and IMU sensors, combining them to create a detailed 3D map of the drone's surroundings. This fusion allows the drone to know exactly where it is, what's around it, and how to react to changes in the environment, whether it's flying over a busy city or a remote forest. With this information, The AI can detect and avoid obstacles on the fly. It's trained on millions of images and scenarios, so it can instantly recognize trees, buildings, power lines, or even birds, and make split-second decisions to dodge them. This real-time learning and adaptation is what keeps drones safe and efficient, even in unpredictable situations. When it comes to navigation, you don't need to micromanage every move. Just set the start and end points, and the AI takes over, calculating the safest, fastest, and most efficient route. It automatically avoids no-fly zones, restricted airspace, and even reroutes around bad weather or unexpected obstacles, ensuring a smooth journey from takeoff to landing. If the GPS signal suddenly drops out, the AI doesn't panic. Instead, it switches to using onboard cameras and IMU data, relying on visual cues and internal sensors to keep the drone stable and on course. This backup system means the drone can keep flying safely, even when traditional navigation tools fail. In emergency situations, AI-powered drones become invaluable. They can search disaster zones for survivors, use infrared cameras to spot heat signatures, and instantly alert rescue teams, all without waiting for human instructions. This rapid response can save lives when every second counts. This level of intelligence is what transforms drones from simple, remote-controlled gadgets into truly autonomous machines. They can take off, land, and complete complex missions entirely on their own, adapting to new challenges as they arise. Thanks to AI, drones are now powerful, independent tools capable of tackling real-world missions, from surveying construction sites to inspecting infrastructure without constant human oversight. This is what makes modern drones so Cekap: smart, reliable, and ready for anything. Autonomous drones are already changing industries. In delivery, companies like Zipline use drones to send medical supplies to remote clinics, saving lives today, not just in the future. In agriculture, drones map fields, spot pests, and help farmers use water and fertilizer more efficiently. During disasters, drones survey damage, find survivors, and deliver emergency kits where humans can't reach. For inspections, drones check towers and bridges for damage, keeping workers safe on the ground. Law enforcement uses drones for surveillance at big events or to track suspects safely. The possibilities keep expanding as drones take on more jobs. These flying robots are already making a real difference. With so many drones in the sky, strict rules are a must. No flying suka-suka. Singapore's aviation authority sets limits on height, no-fly zones, and licensing, especially for commercial use. Break the rules and you could get fined or worse. Privacy is a big concern. Drones with cameras can easily cross the line from helpful to creepy. Safety matters too. What if a drone crashes or worse is used for crime? We need strong laws, responsible pilots, and public awareness to keep drones safe and ethical. It's everyone's job to make sure drones help, not harm, our society. The sky is the new frontier. Autonomous drones will soon be as common as smartphones. Imagine drone highways, swarms building or cleaning, and environmental monitoring from above. But as drones spread, debates about privacy, safety, and jobs will grow. The benefits, saving lives, protecting the planet, boosting industries, are huge. But we must manage risks wisely. Smart regulations, strong security, and public education are key. The journey is just beginning, and how we use drones is up to us. By embracing science and setting clear rules, we can make the skies safe and beneficial for all. The future is flying towards us. Let's be ready, stay alert, and look forward to what's next.